December 1941, Detroit, Michigan. The city sleeps under a thin layer of winter frost, smokestacks belching faint plumes into the gray sky. In vast, echoing factories, the clang of metal is relentless, the heartbeat of a nation at war. Engineers, machinists, and laborers move with precision, turning raw steel, scrap metal, and abandoned machinery into something almost alive. Sparks fly as welding torches kiss cold iron, revealing shapes that will soon dominate battlefields. Outside, train cars rattle with crates of engines, armor plates and turret components destined for ports along the Atlantic, ready to join a growing armada of armored might. Across oceans, Axis commanders glance at intelligence reports and shake their heads. They have faced German engineering, Italian ingenuity, and Japanese naval power. But this tidal wave of production, fueled by a nation that transforms scrap into instruments of war, is unlike anything they have prepared for. Every tank forged, every Sherman rolled out, is a signal. Industrial might can rewrite the rules of battle. The battlefield is no longer decided solely by tactics or courage. The war is now fought in factories. The first Sherman tank rolls off the assembly line. Its journey is just beginning. By late 1941, the global conflict had escalated into a war of unprecedented scale. In Europe, Germany had overrun much of the continent, its blitzkrieg tactics demonstrating speed and coordination that seemed unstoppable. The Eastern Front had opened a brutal theater against the Soviet Union, while in North Africa, Rommel's Africa Corps challenged the British forces across the desert. Meanwhile, in the Pacific, Japan's surprise attack on Pearl Harbor thrust the United States fully into the war. The industrial heart of America, long humming with civilian production, now pivoted sharply toward military output. Factories that once made cars, tractors, and household goods were transformed almost overnight into arsenals capable of mass-producing tanks, aircraft, and artillery. Detroit, often called the arsenal of democracy, became the epicenter of this transformation. Skilled engineers and machinists, alongside newly recruited laborers, including women and minorities previously excluded from heavy industry, worked around the clock. Every inch of factory floor was optimized, every process re-engineered to maximize output. Steel that had once been scrapped from old cars, rail cars, and discarded machinery was melted down and forged into armored hulls. Engines were repurposed, gun barrels cast and rifled, and treads manufactured to precise tolerances. By mid-1942, the United States was no longer just a participant. It was the world's largest engine of war production. This industrial surge was not purely mechanical. Military planners collaborated closely with engineers, creating designs that could be mass-produced while remaining effective in the field. The M4 Sherman, soon to become the backbone of Allied armored divisions, exemplified this philosophy. Designed with reliability and ease of manufacture in mind, it could be built faster and in greater numbers than any comparable German or Italian tank. Engineers faced the challenge of converting limited materials into durable, battle-ready vehicles. Every design decision, from suspension systems to armor thickness, balanced performance against the urgent need for speed in production. Across the Atlantic, the Axis powers monitored American output with increasing concern. German intelligence noted reports of assembly lines producing hundreds of tanks per month, a figure far exceeding even the ambitious calculations of Allied planners. Japanese strategists, too, recognized the looming threat of American industrial capacity, particularly in armored and mechanized units, which could reinforce Pacific operations. For the first time, the Axis realized that victory would no longer hinge solely on battlefield tactics or strategic brilliance. The raw power of industry itself had become a decisive weapon. The human dimension of this effort was equally remarkable. Factory floors were filled with people from diverse backgrounds, women stepping into roles traditionally reserved for men, African American workers overcoming segregation barriers to contribute to essential production, and immigrant laborers drawing on skills brought from across Europe. The sense of shared purpose was palpable, a national commitment translated into sparks, molten steel, and the roar of machinery. Even minor innovations, a faster welding technique, an improved assembly jig, a new method for transporting heavy components, could accelerate production by days or weeks, directly influencing the course of the war. By late 1942, American factories had achieved what many historians now describe as an industrial revolution within a war. The M4 Sherman's production ramped up, along with tanks like the M3 Lee, armored personnel carriers, and self-propelled artillery. Railways and ports worked in tandem to ensure these machines reached the front lines efficiently. Logistics, often overlooked in historical accounts, became as critical as the tanks themselves. An M4 Sherman was only as effective as the network that delivered fuel, ammunition, and spare parts to support it. Yet this industrial might was not without its challenges. Engineers contended with supply bottlenecks, labor disputes, and the constant pressure to innovate under tight deadlines. Despite these hurdles, American production kept pace with, and often outstripped, the demands of global combat. The result was a steady stream of tanks rolling off assembly lines, each one a tangible statement of the United States' ability to turn scrap and ingenuity into decisive battlefield advantage. By early 1943, the strategic picture had begun to shift. While Axis forces still commanded formidable technology and battlefield skill, the sheer volume of Allied tanks, aircraft, and artillery could no longer be ignored. The war was being won in factories as much as on fields of battle. The Germans would soon learn that no amount of tactical brilliance could overcome the relentless output of an industrial powerhouse. The stage was set for the Sherman to meet the Axis on multiple fronts, where quantity and logistical efficiency would often outweigh the superior firepower or armor of enemy. Tanks, this growing dominance of industrial power over battlefield tactics, sets the stage for the next chapter. The angles through which we can understand how scrap and ingenuity reshaped the war, and why Axis commanders came to realize their strategic situation was slipping beyond recovery. By mid-1943, the United States industrial machine had entered full rhythm, churning out tanks, aircraft, and artillery at a pace that no Axis power could match. While German factories struggled with resource shortages, Allied bombings, and the constant threat of sabotage, American assembly lines continued to expand. Shipyards produced Liberty ships in record time. Aircraft plants delivered thousands of P-51 Mustangs and B-17 Flying Fortresses, and armored factories produced M4 Shermans by the hundreds. Each vehicle represented not just steel and machinery, but the coordinated effort of engineers, designers, and a labor force determined to support the war effort. The M4 Sherman became the symbol of this industrial triumph. Though it lacked the thick armor or massive firepower of Germany's Panther or Tiger tanks, it excelled in reliability, maintainability, and sheer numbers. American engineers had designed it for rapid production, standardized parts, and field repairs, features that allowed units to keep moving even after sustaining damage. The Sherman could traverse difficult terrain, operate in diverse climates from the deserts of North Africa to the frozen forests of Italy, and support infantry with consistent firepower. Its advantages were not just in its design, but in its mass availability. While a single Tiger tank could take weeks to manufacture, dozens of Shermans could be deployed in the same time, overwhelming German units by quantity. Logistics played a critical role in amplifying this advantage. Ports along the U.S. East Coast and Gulf of Mexico, such as New Orleans, Baltimore, and Norfolk, were transformed into sprawling hubs of military transport. Trains and trucks ferried armor and supplies across thousands of miles to embarkation points, ensuring that Shermans arrived on battlefields fully equipped and combat-ready. In contrast, Axis supply chains were increasingly stretched, reliant on contested rail lines and vulnerable maritime routes. American engineers had not only created machines of war, but had designed an entire support network around them, a feat that combined industrial foresight with strategic planning. Across battlefields from North Africa to Italy, commanders began to notice the impact. German tank crews, accustomed to confronting fewer enemy vehicles, now faced armored brigades composed entirely of Shermans. The numbers were staggering. American units could rotate damaged tanks back to ports for repair, replacing losses within days. Axis intelligence reports noted the consistency and speed of American replacements, a factor that eroded both morale and tactical flexibility. In essence, the United States had turned production itself into a weapon, one that could blunt the tactical brilliance of the Wehrmacht. The human dimension remained central to this industrial effort. Factories employed more than 2 million workers in armored production alone, many of whom had never touched heavy machinery before 1941. Women, famously known as Rosie the Riveter, staffed welding stations, rivet guns, and assembly lines. African American workers, previously marginalized in industrial roles, were increasingly integrated into skilled positions, contributing essential labor to maintain production quotas. Labor unions coordinated closely with military planners to prevent strikes, ensure safety, and train new employees rapidly. Every innovation, from improved turret casting methods to simplified track assembly, directly translated into more tanks on the battlefield. Allied strategic planning capitalized on these advantages. In North Africa, Sherman supported rapid infantry advances, overwhelming German positions not with superior firepower, but by sheer persistence and numbers. In Italy, the same tanks facilitated breakthroughs across mountain passes and river crossings, often providing the crucial edge in attritional campaigns. By late 1943, Axis commanders recognized that the U.S. was no longer just a distant threat, it had become a war machine capable of sustaining campaigns that their own economies and manufacturing systems could not match. American industrial supremacy also forced technological adaptation among Axis forces. German engineers accelerated the development of heavier tanks like the Panther and Tiger, attempting to counterbalance the numerical advantage of Sherman's. Yet these vehicles required more resources, longer production time, and experienced crews to operate effectively, luxuries increasingly in short supply. Even successful battlefield engagements could not offset the relentless output of U.S. armored production. By the end of 1943, the strategic consequences were undeniable. The Axis could fight battles, but they could not match the continuous flood of American armored units, nor the logistical ingenuity supporting them. Each Sherman rolling off the assembly line was more than a machine. It was a testament to a nation mobilized for total war, demonstrating that victory increasingly depended on industrial capacity as much as battlefield skill. The stage was now set for the detailed examination of the human, technological and tactical angles that defined this industrial advantage, from the laborers shaping steel to the engineers optimizing designs, and the commanders deploying these machines in combat. Understanding these angles is crucial to seeing how the Axis came to realize that the industrial war was already lost. The story of America's industrial triumph in World War II is multifaceted, revealing a series of angles that together explain why the Axis powers found themselves increasingly outmatched. The first angle is human ingenuity and labor. American factories were not merely production lines. They were ecosystems of skill, creativity, and determination. Engineers translated theoretical designs into practical machinery, machinists adapted equipment to maximize efficiency, and laborers performed tasks under extreme time pressure. Women, previously absent from heavy industry, became essential contributors, mastering welding, riveting, and assembly with speed and precision. African American workers, often entering industrial roles for the first time, provided critical support, challenging social norms even as they helped win a global war. Each individual contributed to a broader system, proving that human effort, when organized, trained, and empowered, could amplify technological and industrial capacity to unprecedented levels. The second angle is tactical flexibility afforded by mass production. Axis forces were accustomed to facing opponents whose armored units were limited in number, requiring careful, calculated engagements. The Sherman disrupted this paradigm. While individually less powerful than German Tigers or Panthers, Shermans could be deployed in large numbers, creating overwhelming force through concentration and persistence. Their standardization meant crews could be rotated between tanks without extensive retraining, and damaged vehicles could be repaired and returned to the line rapidly. The tactical implication was clear. American commanders could sustain offensives indefinitely, attriting enemy forces through continuous engagement and forcing the Axis to defend against an unrelenting flood of armored vehicles. Technological pragmatism is another critical angle. Unlike the Axis focus on specialized, highly advanced but resource-intensive tanks, American engineers emphasized simplicity, reliability, and maintainability. The Sherman's design reflected this philosophy. Its 75mm gun, while less formidable than the Tiger's 88mm, was sufficient against most German vehicles at standard engagement ranges. Its suspension, drivetrain, and internal layout allowed repairs to be conducted with minimal tools, even in field conditions. Engineers constantly iterated designs, improving armor layout, engine performance, and track durability without halting production. This balance between effectiveness and manufacturability ensured that quantity could translate directly into battlefield advantage. The fourth angle is leadership and strategic vision. Military planners recognized early that American industrial output could shape battlefield realities. Coordinated efforts between the War Department, the Army Ordnance Corps, and civilian industry allowed for precise forecasting of requirements and rapid adaptation to changing needs. Logistics officers ensured that tanks, ammunition, and spare parts moved efficiently from factories to ports and then across oceans to combat zones. This integration of strategic foresight with industrial capability meant that Allied operations could be sustained on multiple fronts simultaneously, overwhelming Axis commanders who were forced to divide their attention and resources across dispersed theaters. Finally, there is the enemy perception and psychological impact. German and Japanese intelligence closely monitored American production, initially underestimating its scale. As reports of Shermans arriving in overwhelming numbers reached the front lines, Axis troops and commanders were forced to adjust their tactics. The psychological burden of facing unending waves of armor contributed to lowered morale, increased caution, and ultimately, tactical errors. The realization that even elite German units could be outnumbered and outpaced was profound. It underscored the strategic reality that the war was no longer fought only on battlefields but in factories, assembly plants, and logistics networks. Each of these angles, human ingenuity, tactical flexibility, technological pragmatism, strategic leadership, and enemy perception, combined to give the United States an unparalleled advantage. They illustrate why Axis commanders came to understand that defeating America would require more than battlefield skill. It would demand breaking a system fueled by the full industrial and human capacity of an entire nation. These angles provide the framework for examining how the Sherman, born from scrap and ingenuity, would meet the Axis on battlefields across the globe. The next step is to explore Section 2 of Angles, highlighting further nuances of production efficiency, industrial strategy, and battlefield adaptation. The industrial war fought by the United States extended far beyond the factory floor, reaching into every aspect of strategy, innovation, and adaptation. One of the most revealing angles is production efficiency and standardization. American engineers approached tank manufacturing with a mindset of replication and reliability. Components were standardized across multiple production plants, enabling parts to be swapped between vehicles with minimal difficulty. Welding techniques, turret assemblies, and engine mounts followed exact specifications, reducing errors and accelerating construction. This approach allowed factories to maintain staggering output. By 1944, American plants were producing more than 2,000 tanks per month. In contrast, German heavy tank production remained limited, with complex casting and machining processes slowing delivery. Standardization not only ensured quantity but enhanced battlefield readiness. As crews could quickly learn and operate new machines, and repair units could maintain operational readiness with consistent spares. Another crucial angle is technological adaptation under combat pressure. As Sherman tanks faced more formidable German armor, engineers and commanders implemented iterative upgrades. The introduction of the 76mm gun and the development of the M4A3E8 EZ-8 exemplified responsive engineering. Better firepower, improved suspension, and higher speed allowed the Sherman to confront heavier enemy tanks more effectively while retaining its production advantages. Such modifications were made without halting assembly lines, demonstrating the United States' ability to combine innovation with industrial momentum. Every adjustment reflected lessons learned directly from combat reports, highlighting a feedback loop between the battlefield and the factory, a system that the Axis could not match. Logistical mastery forms another defining angle. Massive production meant little without the ability to move, supply, and maintain tanks in theaters far from home. American planners developed integrated supply chains that extended from Midwest assembly plants to European ports and then to frontline units. Rail networks transported armored brigades to staging areas, while trucks and engineering units established forward supply depots. Fuel, ammunition, and spare parts were pre-positioned to sustain continuous operations. This meticulous coordination ensured that Sherman brigades rarely halted for lack of resources, a contrast to German forces, who increasingly faced shortages as Allied bombing and overstretched supply lines strained their capacity. The logistics system turned mass production into a tangible advantage, converting steel and manpower into combat effectiveness. The human angle under combat conditions further reinforces the Sherman's impact. Crews operated in harsh environments, North African deserts with searing heat and sand, Italian mountains with freezing winds, and the muddy fields of northern France. Despite the Sherman's lighter armor, soldiers trusted its reliability, knowing that repairs were possible and replacements were on the way. Morale and confidence were closely tied to industrial resilience, a concept foreign to Axis tank crews facing constant attrition without adequate reinforcements. American soldiers understood that the machine's endurance was inseparable from the nation's industrial will, and that each engagement carried the weight of an entire production ecosystem. Finally, strategic perception by the Axis encapsulates the psychological dimension. German commanders documented the sheer volume and adaptability of Sherman deployments, noting how the numerical advantage often outweighed technological superiority. Reports highlighted the bewilderment of crews who faced waves of tanks that, while individually less lethal, presented relentless pressure. The knowledge that American factories could replace losses faster than battles could destroy them eroded enemy confidence. In essence, the Sherman became more than a weapon. It was a symbol of American industrial inevitability. Each battlefield encounter reinforced the realization that Axis forces were increasingly reacting to production as much as to tactical maneuvers. Collectively, these angles, standardization, adaptive engineering, logistics, crew experience, and enemy perception, illustrate a single, powerful truth. The Sherman's effectiveness derived not from being the most advanced tank, but from being the product of an entire nation's industrial and strategic ecosystem. Axis commanders quickly understood that battlefield skill alone could not overcome an opponent whose advantage lay in both numbers and adaptability. The interplay of these factors shaped the decisive engagements that would follow. This analysis sets the stage for the climax turning point, where the Sherman's mass production, logistical support, and tactical deployment confronted the Axis on European battlefields, forcing pivotal outcomes that reshaped the course of the war. By late 1944, the European theater had become the ultimate proving ground for American industrial power. The Allies were preparing for Operation Cobra, the breakout from Normandy, and Sherman tanks were central to this effort. On July 25, 1944, under overcast skies streaked with smoke from previous bombardments, armored brigades moved forward through the bocage country of northern France. German commanders, expecting cautious attritional engagements, were confronted instead with relentless waves of Sherman tanks, supported by artillery and air cover. The combination of numbers, reliability, and coordination transformed the battlefield. The terrain, previously advantageous for German defenders, offered little cover against massed armor supported by tactical airstrikes. The Shermans advanced with disciplined formation, navigating hedgerows with engineered attachments like the rhino tusk blades that allowed tanks to breach dense vegetation. Each tank carried crews who had been trained not just to fire but to maintain, coordinate, and survive. Repair teams followed close behind, recovering damaged vehicles and returning them to combat. German panzer units, including Panthers and Tigers, found themselves outnumbered and increasingly outmaneuvered. Even the elite SS division struggled to contain this industrial torrent. The tactical impact of sheer numbers became undeniable. A single Panther or Tiger could destroy multiple Shermans, but for every one lost, the Americans could replace 10. On July 26, during the push towards St. Lo, German reports noted continuous enemy armor advancing in waves, replacement tanks arriving almost as quickly as we can fire. This relentless pressure forced German units to abandon defensive positions, leaving strategic points vulnerable and allowing Allied infantry and mechanized units to exploit gaps. The Sherman's moderate speed and standardized design facilitated rapid redeployment, enabling combined arms coordination at a scale Germany could not match. Another critical element was air-ground integration. The P-47 Thunderbolts and P-51 Mustangs provided close air support, targeting German artillery, armored positions, and supply lines. Shermans, moving under the cover of these aircraft, faced fewer concentrated counterattacks, further amplifying their operational effectiveness. Axis forces were caught in a dual challenge, enduring a mechanized advance on the ground while being exposed to overwhelming air power above. German field communications recorded frustration at being attacked simultaneously from air and land, unable to regroup, outnumbered at every turn. This combined arms synergy represented a decisive evolution in Allied strategy. Industrial production was now directly coupled with tactical ingenuity. The human cost and courage on both sides underscored the intensity of this turning point. Sherman crews faced snipers, artillery, and minefields, yet their confidence in maintenance support, supply lines, and fellow soldiers sustained their momentum. German crews, despite superior armor and firepower, confronted the psychological strain of endless waves and the ever-present possibility of being outflanked. Diaries and post-war memoirs describe a growing sense of inevitability, the recognition that tactical skill alone could no longer offset the overwhelming material and logistical advantage of the Allies. By early August, the breakout from Normandy was effectively complete. The Shermans' combination of reliability, adaptability, and sheer numbers had shattered the German defensive lines. The Germans were no longer fighting just tanks. They were facing the industrial might of an entire nation, translated into mechanized form. Reports from captured officers acknowledged this reality. The Americans can replace their tanks faster than we can destroy them. Their will, aided by industry, is inexhaustible. The tide had decisively shifted. This first part of the climax demonstrates that the Shermans' influence went beyond individual engagements. It reshaped operational planning, forced German commanders to disperse forces to avoid being overwhelmed, and ensured that Allied offensives maintained momentum. The combination of production, logistics, training, and tactical innovation created a systemic advantage that could not be countered by technological sophistication alone. The stage is now set for Section 2 of the climax, which will detail the further escalation of armored warfare, key battles across France and the Ardennes, and the pivotal moments where industrial mass met desperate German resistance, ultimately sealing the fate of the Axis in Western Europe. As the summer of 1944 progressed, Sherman tanks advanced relentlessly across France, meeting both determined resistance and the crumbling German front. In the hedgerow country of Normandy, villages lay in ruins, roads choked with wrecked vehicles, yet the American advance barely slowed. The German High Command, still relying on elite Panther and Tiger battalions, recognized that numerical superiority had shifted decisively. Even the most heavily armored units were forced into reactive defense, unable to halt the constant arrival of fresh Shermans. During the Battle of Saint-Lô and the subsequent push toward the Loire, tactical ingenuity compounded the Shermans' numerical advantage. Crews employed combined arms tactics with infantry, artillery, and engineers, clearing minefields and breaching fortifications. Smoke, dust, and debris hung in the air as Shermans advanced, their 75 mm and 76 mm guns targeting fortified positions while maintaining mobility. Reports from German officers describe an unsettling pattern. Every defensive position we occupy is penetrated. Reinforcements arrive too late. Enemy tanks continue forward, undeterred by losses. The psychological weight of endless, armored waves created confusion and forced premature withdrawals. The integration of supply and repair networks ensured that damaged tanks rarely remained out of action for long. Recovery crews operated under fire, towing broken Shermans to field workshops, replacing engines and armor plates within hours. This reliability reinforced the confidence of crews and commanders alike, allowing operational momentum to persist where Axis forces expected delays. Even Tiger crews commanding fearsome machines faced frustration. For every Panther or Tiger destroyed, multiple Shermans replaced it within days, turning attrition warfare into an insurmountable challenge. In the Ardennes, during the German counteroffensive in December 1944, Shermans again proved decisive. While snow, ice, and dense forests created treacherous conditions, American engineers adapted vehicles with improved tracks and suspension, allowing them to maintain mobility where heavier German tanks faltered. Supply lines, pre-stocked and coordinated, ensured fuel, ammunition, and repair materials reached forward units. In contrast, German units struggled with logistics, often immobilized by weather, fuel shortages, or battlefield damage. The Shermans' reliability allowed Americans to stabilize lines, counterattack, and maintain operational initiative despite the harsh winter. The cumulative effect on German strategy was profound. High-ranking commanders began reassessing the war in the West, realizing that technological superiority in individual tanks could not overcome the relentless flood of well-coordinated American armor. Operational reports from late 1944 repeatedly note the challenge. Our heavy tanks inflict losses, but replacements arrive too quickly. Enemy morale remains high and their industrial support is limitless. The battlefield itself had become a testament to American industrial supremacy. Victory was now inseparable from production capacity, logistical foresight, and tactical adaptability. Moreover, the Shermans' impact extended beyond direct combat. German reconnaissance reports and intelligence assessments documented a transformative psychological effect on troops. Facing a seemingly endless tide of American tanks, soldiers began to question the sustainability of their positions. The realization that each destroyed tank was quickly replaced, and that Americans could deploy new formations without pause, created a sense of inevitability. Even elite panzer divisions, once feared across Europe, faced the crushing truth. The industrial and logistical backbone of the Allies had overtaken battlefield expertise. By early 1945, Allied armored brigades had broken through the Siegfried Line and pressed into the heart of Germany. The Sherman, though technically inferior to many German designs, had achieved strategic dominance through a combination of reliability, production scale, tactical innovation, and logistical support. Individual losses mattered little. The systemic advantage ensured that every battlefield engagement contributed to an unstoppable march toward victory. Reports from captured German officers, post-war memoirs, and archival analyses confirm this. The Sherman had transformed the nature of armored warfare, demonstrating that industrial mass integrated logistics and human ingenuity could overcome even the most formidable technological threats. This section of the climax underscores the decisive turning point in Western Europe. The Axis, confronted with an opponent whose battlefield effectiveness was amplified by unmatched industrial and logistical coordination, had no capacity to regain momentum. The Sherman was not merely a vehicle, it became a symbol of American ingenuity and industrial determination. Its presence on the battlefield ensured that the war in Europe would be decided not by a few heroic machines, but by the strategic orchestration of an entire nation's productive capability. With the battlefield outcome secured, the next section, Aftermath, will explore the consequences of this industrial dominance, the destruction faced by German forces, the shift in military psychology, and the profound implications for post-war armored strategy. By the spring of 1945, the full impact of American industrial warfare was evident across the Western Front. German defenses lay shattered, cities and towns reduced to rubble, and the once formidable panzer divisions were mere shadows of their former strength. Reports from the German High Command confirm staggering losses. Thousands of tanks, vehicles, and artillery pieces destroyed or abandoned, and a military stretched beyond its logistical limits. The Sherman, though not as heavily armored or armed as the Tiger or Panther, had achieved victory through reliability, numbers, and strategic deployment. Each tank lost was swiftly replaced, turning what the Germans hoped would be attrition into an insurmountable disadvantage. In the liberated territories, the psychological impact of continuous armored advances was profound. German civilians, soldiers, and local authorities observed the disciplined yet relentless movement of American brigades. The combination of mechanized power and logistical efficiency created an aura of inevitability. Memoirs from German soldiers describe the growing sense of despair. Even elite units could not stem the tide. In towns like Aachen and Cologne, entire panzer battalions were destroyed or forced to retreat in disarray, leaving defensive positions untenable and opening corridors for the advancing Allies. The American logistical network, often overlooked in wartime accounts, had become a decisive instrument of power. Sherman tanks could operate continuously because of meticulously coordinated supply chains delivering fuel, ammunition, and spare parts. Repair units moved with the front, recovering damaged vehicles and returning them to combat at unprecedented speeds. This system transformed industrial capacity into battlefield dominance, demonstrating that the ability to produce and sustain military hardware was as crucial as tactical skill or technological superiority. On the German side, losses were not just material but psychological. High-ranking officers, including remnants of the Wehrmacht and SS command, recognized that the war was no longer winnable through tactical brilliance alone. Field communications recorded moments of grim resignation. Our tanks are superior individually, but the Americans replace theirs faster than we can destroy them. Every position we hold is eventually overrun. The cumulative effect of continuous armored pressure, combined with air superiority and logistics, forced German units into constant retreat, accelerating the collapse of organized resistance across the West. The battlefields themselves bore the mark of this industrial approach. Roads were littered with wreckage, burned-out Shermans, Panthers, and Tigers, while makeshift supply depots and repair units exemplified the American capacity for sustained operations. Photographs and post-war analyses confirm that many German armored formations were immobilized not by direct destruction, but by fuel shortages, mechanical failures, or logistical bottlenecks, while the Shermans continued forward, repaired, and replenished. This systemic efficiency highlighted a key lesson. Victory was no longer defined by the strength of a single tank model, but by the ability to maintain operational tempo across an entire theater of war. Civilian infrastructure, while not the primary target, suffered as collateral. Towns and villages were affected by repeated engagements, yet American forces prioritized operational speed over deliberate destruction. Occupied regions began to witness the contrast between Axis desperation and Allied organization. The ability to sustain an advance without total disarray became a hallmark of American armored operations. As the Allies pushed toward the Rhine, German commanders increasingly recognized that the war's outcome had been determined not by battlefield tactics alone, but by the unrelenting capacity of American industry and logistics to convert raw materials into combat power. The Sherman, humble in design but extraordinary in its systemic impact, became the symbol of this transformation. It was not merely a weapon of war, but a manifestation of an entire nation's industrial and organizational might, and the consequences of its deployment would resonate far beyond the final surrender in May 1945. The scene is now set for Section 2 of Aftermath, which will delve deeper into the strategic and psychological consequences of Allied armored dominance, the human cost of industrialized warfare, and the lasting lessons for military planning and armored doctrine. As Allied forces pressed deeper into Germany, the systemic advantage of American armor became undeniable. Sherman brigades moved with relentless coordination, striking at weakened German positions and exploiting every gap in the collapsing front. Cities such as Frankfurt, Bonn, and Dusseldorf saw defensive lines crumble, with German tank units often abandoning vehicles and fortifications in haste. Reports from the Oberkommando der Wehrmacht lamented, "Our finest units are destroyed or scattered. The enemy advances with inexhaustible resources." This was a war no longer of isolated encounters, but of industrial scale, an armored onslaught fueled by production, logistics, and human determination. The psychological toll on German troops and commanders was immense. For soldiers, the sight of an endless tide of Sherman tanks, supported by artillery and aircraft, shattered morale. Diaries and post-war accounts describe the pervasive feeling of futility. Despite skill, courage, and superior individual equipment, resistance seemed pointless against a force that could replace losses faster than they could inflict them. Even the elite Waffen-SS divisions, long considered the backbone of German armored power, faced demoralization. High-ranking officers recorded the impossibility of sustaining front lines. "Every counterattack we mount is absorbed. Every tank we destroy is replaced." American crews, in contrast, displayed confidence rooted not in technological superiority, but in the reliability and consistency of their equipment. Shermans could traverse difficult terrain, recover quickly from damage, and operate in tandem with infantry and air support. Field engineers and mechanics ensured operational continuity, and combined arms tactics magnified their impact. Observers noted that this systemic efficiency created a battlefield rhythm the Germans could not disrupt. Forward momentum was constant, deliberate, and unstoppable. The consequences of this industrialized warfare extended beyond immediate tactical victories. German military doctrine, which had long emphasized superior firepower and strategic finesse, proved insufficient against the sheer scale of Allied production. For historians and post-war analysts, the Normandy breakout and subsequent campaigns exemplify a shift in warfare. Strategic advantage now depended as much on the ability to sustain forces as on individual battlefield skill. Shermans, though modest in design, embodied this shift. Their presence illustrated that wars could be won not solely by the strength of individual weapons, but by the organizational capacity to deploy, sustain, and multiply them across a theater. Civilian populations witnessed this overwhelming force firsthand. Towns and villages were transformed by the ceaseless advance of mechanized units. Supply columns, field hospitals, and repair workshops moved in tandem with combat formations, maintaining operational tempo while mitigating civilian disruption where possible. The contrast with German logistical collapse was stark. Shortages of fuel, ammunition, and spare parts immobilized armored divisions, leaving streets and crossroads littered with abandoned vehicles. The Sherman's dependability highlighted a key lesson in modern warfare: Industrial efficiency was as decisive as battlefield valor. By the time Allied forces reached the Rhine and crossed into central Germany, the strategic and psychological effects were clear. The Germans had lost not only men and machines, but also the will to resist in a coherent, coordinated manner. Sherman's contribution to this outcome cannot be overstated. It exemplified the integration of industrial capacity, human ingenuity, and tactical application, demonstrating that victory in modern warfare was inseparable from the ability to maintain operational sustainability. As the war in Europe drew to a close, historians would look back at the Normandy breakout, the push through France, and the Ardennes as pivotal moments where industrial power eclipsed tactical brilliance. The Sherman tank, humble in armor but vast in systemic influence, became a symbol of this new era. The aftermath of its deployment offers enduring lessons. The decisive value of logistics, the integration of mechanized forces with air and infantry support, and the transformation of battlefield psychology under the relentless pressure of industrialized warfare. This sets the stage for closure, where the broader implications of the Sherman's role, industrialized combat, and human resilience will be explored in a contemplative, historically grounded conclusion. The story of the Sherman tank and world. War II is not one of sheer technological brilliance but of systemic mastery. Alone, a Sherman could not outgun a Tiger or Panther, yet collectively, it became an instrument of inevitability. Its strength lay in reliability, mass production, and the logistical foresight that allowed it to fight, break down, be repaired, and return to the battlefield repeatedly. In its tracks, the Axis powers discovered a truth. War could no longer be won solely through skill or superior design. Industrial and organizational power had become decisive. Beyond steel and firepower, the Sherman symbolized the human dimension of modern warfare. Crews endured mud, snow, and shellfire, yet they moved forward, supported by engineers, mechanics, and supply networks. Their perseverance mirrored the broader Allied effort, a society mobilized not just to fight, but to sustain, repair, and innovate. Each tank replaced, each battlefield repair conducted under fire was a testament to ingenuity, coordination, and collective resolve. The German experience, conversely, reflects the limits of technological mastery without systemic support. Elite crews commanding the finest armor of the era faced a relentless enemy tide. Every tactical victory was overshadowed by the relentless influx of Shermans, demonstrating that battlefield heroism could be overwhelmed by production and planning. It was a lesson in the modernity of warfare, industrial capability, integrated. Logistics and human endurance together shaped the outcome of conflicts as profoundly as individual skill. Historically, the Sherman's impact extends far beyond the Western Front. It reshaped armored doctrine, influenced post-war military planning, and highlighted the inseparable link between a nation's industrial base and battlefield success. It stands as a reminder that war is not only fought with weapons, but with the infrastructure, ingenuity, and coordination that sustain them. In the final analysis, the Sherman tank embodies both the practical and philosophical dimensions of World War II. It teaches that true power lies not only in the weapon, but in the human and organizational systems that wield it, a convergence of steel, strategy, and resilience that left an indelible mark on history.